All right, so these are the solutions to pretest 1 on factoring, and we already put up 8, 9, and 10 as video solutions, so you're going to see 1 through 7 here. Um, Starting with number 1, pretty obvious this is a difference of squares. X squared minus 16, it factors pretty easily to x plus 4, x minus 4. Of course, either order by commutativity would be accepted. And the other vocabulary word that's kind of important in here is conjugate. These two things are forming a conjugate, what we call a conjugate pair. And by a conjugate pair, just in general, we're referring to a plus b times a minus b, and again, either order. Um, so that's question 1. Question 2, we've got x squared minus 10x plus 25. It's simple quadratic to factor, and um, really from the high school realm, x minus 5 times x minus 5 will produce the desired result there. Um, Also noteworthy, that could be written as x minus 5 to the second power, since you're multiplying a quantity times itself. Um, and probably also noteworthy that when you're squaring a binomial, you end up with the square of the first term. So x times x is the x squared. The plus the square of the last term, and minus 5 times itself is going to be the plus 25. And then you end up with what we call double the cross product. Well, the cross product is negative 5x, and if you double that, you're going to get minus 10x. So being able to do those kinds of algebraic manipulations really quickly is a good foundation for the calculus. Um, Question number 3, we have x to the fourth minus 81, and that is a difference of squares of sorts. It can be factored into the form x squared minus 9 times x squared plus 9. Well, that's factored, but it isn't factored completely because x squared minus 9 is identifiable as a difference of two squares, and so that then is factored further into an x minus 3 times an x plus 3. And from there you are finished. Uh, and except for order, that would be your answer. Um, so that's question number 3. Um, from there, if you slide down and get rid of some of this stuff, take just a second to do that. A little bigger eraser would be handy. And then look at questions 4, 5, and 6 here. A little too far there. Um, number Number 4 is x squared minus 3x minus 48. And this gives a little exercise in generating factors. Um, we, of course, know if this thing factors over the integers, we're going to have an x and an x. And then by looking at the second sign, the minus 48, we know the signs are different, so it has to be a plus and a minus. And you'd be surprised how often finding factors of numbers becomes an issue in the calculus. So, little trick, I'm going to use the double cut in half technique here. So, if 1 times 48 is 24, then double the 1, get 2, cut the 48 in half, get 24, and continue in that fashion. We get 4 times 12, of course, is 48, and 8 times 6 is 48, and then 16 times 3 would be 48. And then we compare those factors to the b value, and the b value is negative 13, and so we're going to use the 16 and the 3 pairing, and we want the 16 to be with a negative, and we want the 3 to be with a positive. And again, I want to emphasize right there that you're done. You factored it. That's over. These are not quadratic equations, but rather quadratic expressions, and so all you're being asked to do is factor, and you're finished right there. Of course, in terms of commutativity, you can have the x minus 16 first and the x plus 3 second. Um, Question number five, maybe an example of using the AC method um, with a 2 as the A value and a 15 as the B value. The AC product is then 30. And if we look at all the factors of 30, we have 1 and 30, we have 2 and 15, we have 3 and 10, we have 5 and 6. And of course, because we have a B value of minus 1, uh, rather plus 1, then we know we want the 5 and the 6 as the factors. And so using this AC method that we talked about in the video, um, it'll be 2x squared, and we're going to expand that middle, and I'll use a plus 6x and a minus 5x. Of course, the order doesn't matter, but just put the 6x first and the minus 5x second. And then from here, we do something called factoring by grouping or pairwise factoring. So we're looking at this first pair right here, this 2x squared plus 6x, and realizing that they have both 2 and x in common. And when we factor out the 2x, when we divide out the 2x from each term, we're left with an x plus a 3. And when you look at the last pair, of course, the negative sign here, going to factor out a negative 5. It's not an s, that's a 5. And when we factor out that negative 5, when we divide out that negative 5, we're left with a plus x and a plus 3. And so right there, you can see that the two pairs share a factor of x plus 3, and so you factor out the x plus 3, and from there, you get your final answer of x plus 3 times 2x minus 5. So that's the solution for number 5. Uh, Number 6 is an example of um, pairwise factoring. And if you look at the first pair there, the 10x cubed plus 15x squared, of course we have multiple of 5, and they have x in common. And in general, when you have a variable with the same base, you want to factor out the lowest exponent you see here. So we're going to factor out the x squared. And that's going to leave you with a 2x plus 3 from that pairing. And then as you look at the last pair, the plus 4x plus 6, they both share a multiple of 2, so we factor out a plus 2, divide out a plus 2 from each term, and that leaves you with a 2x plus 3. And with a 2x plus 3 as a common factor on each one of these, we can factor out that 2x plus 3, we can factor out that common element, and be left with our final answer of the quantity 2x plus 3 times the quantity 5x squared plus 2. And now those are algebraically prime. There's nothing more you can do with those. So there's the answers to 4, 5, and 6. And just practicing those basic high school techniques, because they are so often found in the calculus and in the exercises that you'll see there. Clean this up again and look at question number 7. And so question 7 is fairly straightforward. 2 times x squared minus 8. Factoring first the 2 and being left with x squared minus 4. And if you left your answer as that, of course, it would be incomplete because the x squared minus 4 is a difference of squares. And so we want to factor that into an x plus 2 times an x minus 2. And that would then be a final answer for question number 7. So now all the solutions to the pretest have been made available, and tomorrow we'll talk to you a little bit about the connections between these basic high school concepts of factoring and how they relate to and how they're found in the calculus. And so we'll talk to you then.